So this one is October, November 2022, paper 2. Ethene can undergo a complete combustion as shown. Some bond energies are given. The energy change for this reaction is negative 1408 kilojoule per mole. We have to find the bond energy for CO. So first, an ethene is there and four CH bonds, because the idea is that the bond breaking energy minus the bond forming energy is equals to enthalpy change. Some of the energy is used to break the bond, some of the energy released when the bonds are formed, and the total energy is equals to enthalpy change. Now, bond breaking energy, 1, 2, 3, and 4 bonds are there, 4 CH bonds, so 4 into 404 into 412 plus carbon-carbon double bond is there, which is 612. Then oxygen-oxygen double bonds are there, and 3 of them, so 496. So 4 into 412 plus 612 plus 496 times 3. What's the final answer? That will give us the total bond breaking energy. So 3748 is a bond breaking. Bond forming energy, we have we have to find for CO. So if one is X, another one is X, but how many molecules are there? There are two molecules of carbon dioxide. So it is OC double bonded. One is X, another one is X. But there are two molecules, as I mentioned, the 2 is there. So two molecules of carbon dioxide. So how many CO bonds will be there? There will be 4 CO bonds, or we can say 4X. So this will be why 4X, because one molecule contains 2 CO bonds. So two molecules contain 4 CO bonds. That's why 4 into CO, or you can also say 4 into X. It's up to you. You can represent by X or you can represent by the bond. Plus 4 like water molecule, one water molecule, HONH, but they, how many are there? 2 of them. So how many OH bonds are there? Total OH bonds. So it will be 4 into OH. So this will be 4 into X plus 4 into OH. The OH bond energy is 463. So we write 463. So 463 times 4, that is 1852. And this total, because we have the formula, the bond breaking energy minus the bond forming energy is equals to enthalpy change. The bond breaking energy 3748 minus the bond forming energy is 4x plus 1852. And that is equals to negative 1408. Now we have to simplify to get the value for x. So now a mathematical equation, you have 3748 minus 4x minus 1852 is equals to minus 1408. So this will move other side, like towards left, and 4x towards right. So we'll have 3748 minus 1852 plus 1408 is equals to 4x. 4x we move other side, and 1408 towards the left hand side. So 3748 minus 1852 plus 1408. That's equal to 3304 is equals to 4x. We need x, so we'll divide it by 4. So 3004 divided by 4, that's equal to x, and that will be 826. So 826, which is option C, so C should be the right answer. Is it clear, this one?
Yes, sir.
The diagram shows an experiment. An aqueous solution P is there and a solid Q is there. A small volume of a aqueous P is poured into a solid Q and the tap of the funnel is closed. Which pair of a substance causes a syringe to be filled with a gas? Magnesium plus nitric acid. So it will give magnesium nitrate. Magnesium plus nitric acid, what will the result? The result will be magnesium nitrate. Acid react with the metal, give salt and hydrogen. So there is a gas given off. So yes, it will work. Copper plus hydrochloric acid. There will be no reaction. Why there is? Because copper does not react. Yeah, hydrochloric acid and copper won't react. So there will be no reaction. And those who want to participate, they can also answer, like use the chat to answer as well. And when sodium carbonate is there, Na2CO3 reacted with sulfuric acid, which is H2SO4. As a result, what it will give? It will give sodium sulfate, the salt, plus water H2O plus carbon dioxide CO2 will be there. So nitric acid and magnesium nitrate will give a gas. This will also give a gas. But B, why copper won't react? Because as I mentioned, in a lab, we always use a dilute, H and aqueous dilute acid is our use. So that's why it does not react. So copper reaction in the lab are not possible as we are using a dilute acid. Is it clear, this one? Which sample does not contain a number of atoms equal to Avogadro's constant? First, we'll find the moles of nitrogen. How to get the? I will solve for each. Like first, we'll find the moles of nitrogen. We have the mass in gram. Moles equal mass in gram divided by molar mass. Nitrogen is N2, so 14. So this will be 0.5 mole. Now, one molecule, like we have 0.5 moles of nitrogen molecule, but we want, the question is which sample does not contain a number of atoms equal to Avogadro's constant, like which is equals to 6.02 into 10 power 23. So what is the relation between molecule and atom of a nitrogen? If we have one molecule of nitrogen, it will have two atoms because N2 means two atoms will make one molecule. So if we have 0.5 moles, how many moles of atoms will be there? X. So how many moles of atom we'll get when we cross multiply? We'll get 1. If we are getting 1 mole, it means it will always have 6.02 exponent 23 particles or atoms will be there. So nitrogen is having like 0.5 moles of nitrogen molecule contain 1 mole of nitrogen atoms. So, and 1 mole of nitrogen atom means it will have same like the Avogadro's number of particles will be there. You have 0.5 moles of nitrogen. Then we take a ratio between a nitrogen molecule because we have a molecule of a nitrogen and the question was about number of atoms. So what was the relation between a molecule and atom for nitrogen? If we have one nitrogen molecule, it provides two atoms. So the ratio between a molecule to atom is 1:2. So if we have 0.5 moles of nitrogen molecule, how many atoms will be there in that X? We just cross multiply and we get 1 mole of atoms. And 1 mole of atom will contain Avogadro's number of particles. So that's why A is not, A is having Avogadro's number, but the question is which does not contain. Now, when we check for the second one, to find the moles of water, it will be 6 divided by 18. 6 divided by 18 is 0.33. Now, what is the relation between one molecule for water and atoms? One molecule, how many atoms are there? So the ratio between molecule and atom is like one molecule contain like two hydrogen and one oxygen. So how many atoms are there? Three atoms. So 1:3 is the ratio between molecule and atom. So if we have 0.33 moles are there, how many moles of atoms will be there? X. When we cross multiply, 0.33 multiplied by 3 is approximately 1. Not exactly, but approximately it is equals to 1. So we are getting a 1 answer. Is it clear about B? Like how we are getting one mole? So first we get the moles of a molecule and then we are finding moles of an atom. Then for the third one, for helium, moles equal mass in gram divided by molar mass. Helium is a monoatomic, so it will be 4, so we get 1 mole. So actually 1 mole of helium is having 1 atom only, so again it is 1 mole. But for carbon dioxide, the carbon monoxide, 28 gram divided by 28, so we got 1 mole. And what is the relation between a molecule of carbon monoxide and the atom of the carbon monoxide? The ratio between them is 1:2. Like one molecule gives 2 atoms. So if we have 1 mole of molecule, how many moles of atoms will be there? 2 moles of atoms, or it won't be Avogadro's number. It will be double of Avogadro's number. So the answer should be D. Is it clear? Then electrical energy or voltage of a two simple cell is measured. The question is which options are correct? Zinc and magnesium are there, and zinc and copper. We have the reactivity potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, copper, mercury, silver, gold, and platinum. The first statement, the voltage of cell 1 is greater than cell 2. So cell 1 is zinc and magnesium, and cell 2 is magnesium and copper. So cell 1 voltage will not be more, it will be less because smaller difference in the reactivity. Cell 2 voltage will be higher. So because voltage of cell 1 is greater than cell 2 is wrong because they have a smaller difference in reactivity. So the statement 1 is totally wrong. So any which options are correct? Any option with statement 1 is wrong because so all statements are correct is totally wrong. Only statement 1 is correct. 1 and 3 are correct. 1 is wrong. Statement 2 is correct. And explain statement 1. What is zinc is more reactive than copper? From this cell, yeah, because the difference in the reactivity is there. What about the statement 2? Statement 2 is zinc is more reactive than copper. This statement is correct. As we know, like zinc is more reactive than copper. But the voltage of a cell, because the statement 1 is explain and explain statement 1 is wrong. So statement 1 is totally wrong, even though statement 2 is correct, but statement 1 is wrong. So that's why this option is also incorrect. What about statement 3? Magnesium oxidize in both cell. Oxidize means magnesium will lose electron. Because magnesium is more reactive, so it will lose electron and turn into magnesium ion. Magnesium will turn into magnesium ion and the electron transfer from magnesium to zinc and here magnesium to copper. So magnesium oxidized, that's correct. And magnesium atom oxidized means like it will lose electron. So statement 3 and 4 are correct and statement 4 is correct and explain statement 3. So that's why D is the right answer. Is it clear this one?
Yes, sir.
Why is statement 1 wrong if zinc is more reactive? No, why statement 1 is wrong? Because the voltage of cell 1 is greater than cell 2. That is wrong. Yeah, the reason is that because if you see zinc and magnesium, the voltage of cell 1 is not greater. The voltage of cell 1 should be smaller than cell 2. So even this statement is not true. It is a false statement. If it was, the statement was like this, for example, if the same question was there and statement was the voltage of a cell 2 or cell 1 is smaller than cell 2 and zinc is more reactive than copper, then we will say that statement 2 is correct and statement 1 explain that idea. Because when the metals, two metals are having a smaller difference in the reactivity, the voltage produced is smaller. If a voltage, if a greater difference in reactivity, then the voltage produced will be higher. So statement 1 is totally wrong. Like it's not correct statement. So how it can, if a wrong statement is there, then how it can explain the correct results? Is it clear? Two is not explaining the statement. Statement two is correct. That till here it is right. That statement two is correct. And it explains statement one, that is wrong. It does not explain statement one. If it's statement, because statement one is totally wrong. Statement one state that cell one is having a greater voltage, but the cell one cannot have a greater voltage. It should have a smaller voltage because the difference in the reactivity, and you check the difference in reactivity between magnesium and zinc, it is a smaller difference as compared to magnesium and copper. So the voltage here will be smaller voltage, and voltage between magnesium and copper should be a higher voltage. Which compound has the most CH groups in one molecule? So you can draw the structure to identify butane. But means 4 carbon. This will have 3 hydrogens. This will have 2 hydrogen. This will have 2 hydrogen, and this will have 3 hydrogen. So how many CH groups are there? CH2 groups, one CH2 group, another CH2 group. 2 are there. For butanoic acid, but means 4 carbon, and oic acid C double bonded with O, ONH. The question is how many CH2 groups are there? Means carbon attached with 2 hydrogen. So when you draw the structure of butane, but means 4 carbon atoms. So but means 4 carbon atoms are there. So this is not a CH2 group. This is a CH3 group at the end. This is CH3, carbon attached with 3 hydrogen, carbon attached with 3 hydrogen, then 2 hydrogen and 2. So these are CH2 groups. The end is CH3 groups in butane. In butanoic acid, so this will be the structure of butanoic acid. How many CH2 groups are there? So this is one CH2 group and this is another CH2. Also 2. Then butane 1 all. Butane 1 all. But means 4 carbon and 1 all means OH attached with the first one. So this will have 2 hydrogen. This will have 2 hydrogen. This will have 2 hydrogen and this will have 3 hydrogen. So when we check the number of the CH2 groups, this is one CH2, this is another, this another. So 3 CH2 groups are there in butane 1 all. And when we check for but 1ene, but means 4 carbon. And there's a double bond. So this will have 2 hydrogen. But there is a double bond here because it's but 1ene. So 4 carbon, this will have 2 hydrogen, this will have 3. So when we check the CH2 group, so this is CH2, this is CH2. Rest all of them are like this is CH3 is there, and this is CH. So there are 2 groups. So 2 here, 2 here, 2 here, but this will have 3. So yeah, butane 1-all. What is the structure of butane 1-all? But means 4 carbon. So we draw 4 carbon, 1, 2, 3, 4. And 1-all means the OH is attached with one of the carbon, the first carbon. You can attach from right, you can attach from left. It does not make difference. Then this carbon, they are all single bonded. So this carbon, 2 bonds are available, 1 hydrogen up, 1 hydrogen down. This also 2 bonds available, 1 hydrogen up, 1 hydrogen down. 2 bonds available, 1 hydrogen up, 1 hydrogen down. 3 bonds available, 3 hydrogen. So how many CH2 groups are there? This is 1, this one is 2, and this one is 3. That's why C is the right answer. Yeah, one of the carbon attached to OH, but that is not, the thing is which molecule contains CH2 group. That CH2 group might be attached with anything, that does not matter, because they did not say that CH2 must be attached with oxygen or a carbon. They just said that which molecule contain, which compound has the most CH2 groups in one molecule. Is it clear, this one? Any other question from October, November 2022 paper? The chemistry?